In the last video, we derived the law of sines, and then we used it to solve triangles. So in other words, finding all the sides and all the angles of a triangle. And the big idea is that we can now work with non-right triangles. In this lesson, we're going to take a look at a few applications of the law of sines. The first application is finding area of triangles. So from geometry, we're used to thinking of the area of a triangle as 1/2 base times height, or sometimes people write it as base times height over 2. So let's just use that quickly to find the area of this triangle. If we take 1/2, multiply it by the base, which is 21, and then times the height, which is 8. I'll actually do 1/2 times 8 first, which is 4, and then 4 times 21 would be 84. And we weren't given any specific units, so I'll just say units squared. But the problem is we're not often given the height of the triangle like this. A lot of times we just know the side lengths and the angles. So we're going to have to pretend like we don't know the height of this triangle. I'm just going to label that as h for now. And I'll also go around the triangle and label all the angles and sides. So now we have more of a generic triangle. But let's see how we can find the area of it. I'm going to start out with the formula we know, so 1/2 times base times height. And the reason is we do know the base of this triangle. And ironically, I labeled the base as b, so I'm just going to leave that as a b. But somehow I need to change this h into something else because I'm not given the height of the triangle. But let's say I knew this angle c. Well, if I look at angle c, if I took the sine of angle c, that would be opposite over hypotenuse. Now, of course, if I'm taking the sine of c, I'm thinking about a right triangle, and that would be this right triangle here on the right. So even though I don't know this height, I'm still going to just write this as sine of c is h over a. And then if I just multiply this a over to the left side, I would have a times the sine of c equals h. So again, I don't know what this h value is, but I do know the side length a, and I do know the angle c. So then I can take this h here and just replace it with a times the sine of c. And that's really all there is to it, because now we have a formula for area using just these two side lengths b and a, and some angle c. I'm going to rewrite this though just a little bit nicer, so 1/2 times a times b times the sine of c. Now, you might not be given specifically the sides a and b and the angle c. You might be given the sides b and c and angle a. So this is just another form of this area formula. And if you weren't given a and b, or b and c, let's say you were given a and c, so this would be 1/2 ac sine of angle b. So the way I remember these is just that you have two sides and then the other letter angle. So now that we know the formula, let's take a look at two examples. In number 1, we have angle b is 130 degrees, side a is 62, and side c is 20. And if you look at the letters for the sides, we have a and c, and then the angle is b. So this is perfect. We have two sides and then the other letter angle. So I can plug this into the formula that we know. So I'll write 1/2 times the two sides, so 62 times 20. Maybe put these in parentheses just to keep it organized. And then times sine of the angle. So sine of 130 degrees. And then just type that into your calculator, make sure you're in degree mode, and you should get 474.95. And again, we weren't given units, but I'm going to label this as units squared. And I think that's just a nice thing to add since we are finding area, like we're not just solving an equation or something. In number 2, we're given sides b and c, and then the opposite letter angle, so a. So to find the area, I'll write 1/2 times the b value, which is 4.5, times, in this case, the c value was 22, times the sine of the angle. And they wrote it as 5 degrees and 15 minutes. Remember, there's 60 minutes in a degree, so 15 minutes would be like a quarter of that. So this would be 5.25 degrees. If you just plug that into your calculator, you should get 4.53. Again, I'll label this as units squared. So these area problems really go pretty quickly. Our last example is a word problem. It says, a pilot just started on the glide path for landing at an airport with a runway length of 9,000 feet. The angles of depression from the plane to the ends of the runway are 17 degrees and 19 degrees. Find the altitude of the plane. Alright, so we have our airplane. It's slowly descending towards the runway, which is 9,000 feet long. And notice how I labeled the angles of depression. When you're talking about angle of depression, you have to label it or measure it from like a horizontal line of sight. So looking straight forward from the plane would be parallel to the ground. Even though the plane is like coming down at an angle, we still have to think of angle of depression as being measured from a horizontal line. So they told us those angles are 17 and 19 degrees. And we're asked to find the altitude. I label that as h for height. And the runway doesn't extend over here, but this is like the ground level, so I will draw that in. And you can see we have the small right triangle on the left of our picture. And that's nice. We're used to working with right triangles. But most of the information we're given does not have to do with that right triangle. Most of the information has to do with like this bigger obtuse triangle over here. So the first thing I'm going to do before we really dive into the problem is just label a few more values that I can get kind of quickly. Like I know if this is 19 degrees, this angle down here would be an alternate interior angle, so that would be 19 degrees as well. Because I'm looking at the ground and then this horizontal line as being parallel, and then this is like a transversal cutting through them. So there's our alternate interior angles, so those are both 19 degrees. And same thing here, if this smaller angle is 17 degrees, that means that this angle would also be 17 degrees. Alright, so at this point, if I'm trying to find the height of this right triangle, it'd be nice if I knew one of the other sides of this triangle. Because then I could set up sine of this angle being like opposite over hypotenuse, that would work out really well. Or if I did tangent of 19, then I could do opposite over adjacent. And I noticed that if I think of taking the sine of this angle as opposite over hypotenuse, this hypotenuse side length that I'm talking about is actually one of the side lengths of this bigger triangle over here. So that's actually going to be my main goal. Let's try to find this side length first, and then we can use that to find this height. And since this lesson is covering applications of law of sines, let's think about using law of sines. Now in the last video, when we were solving triangles, all of the sides and angles were labeled for us, so we just had to like plug it in the formula. This one's not labeled the same way, but remember how you're always looking to match up like a side and an angle. So like side A over sine of angle A. So that's like a pair of opposite sides and angles. And right now, if I'm looking for this side, the angle opposite from that side is this 17 degrees way over here. It doesn't really seem like it's the opposite, but it's obviously not this obtuse angle because that's touching that side, and it's obviously not this tiny angle up here, which, by the way, that tiny little angle up there would be 2 degrees. Okay, so I know I'm looking for this side. I'm just going to call that A for right now, and then we could set up A over the sine of the opposite angle, so sine of 17 degrees, equals, and then we just need a side and an angle opposite from each other on the triangle. And we know this 9,000 on the bottom, and that's opposite from this angle up at the top. So I'm going to say 9,000 over the sine of 2 degrees. And then to solve this, I would just want to multiply that sine of 17 degrees over to the right side. Type that all into your calculator, and you should get 75,397.80. I think this came up in the last video too, but I'm including this 0 here. I know you don't really have to write the 0, but I'm including that to show that I rounded this value to the second decimal place. But that's not actually the answer we're looking for in this problem. Remember, I want to find the side length that I labeled as h. And now I'm going to set up that sine equation with this angle here. So sine of this angle would be opposite over hypotenuse. So h over the side length that we just found, this a here. And now just multiply the denominator out of there. And now you should get that h equals 24,547.12. And we were given units in this problem. We're talking about feet. So that's our final answer. So just a couple general tips for these word problems. Sometimes alternate interior angles are still really helpful. And also, just because we're talking about law of sines and we can now solve non-right triangles, it's still helpful to use right triangles in the diagram sometimes. So still be on the lookout for those. And that should get you started with application problems dealing with law of sines.